All right, inserting data into tables then. Obviously, I can just insert a row and I can specify the values that I want to insert into that. So I could explicitly say, insert a product with this product ID, this name, this price, this color, and whatever. I can specify those values. If the table that I'm inserting into has an identity column, so you want to just quickly remind us what an identity column is.
So a lot of our IDs we've seen have numbers, and they're unique. They have to be unique because that's it's what's called a primary key. It uniquely identifies that row. One way, straightforward way of making sure that's unique is making sure that we have a counter. So the first one is number 1, next one number 2, 3, 4, 5, 6, 7, and automatically it would generate the next number. We can actually, in SQL Server, tell it not to go in 1, 2, 3, 4, 5. You can make it jump a few as well if you wanted to. So you could actually deliberately make it do every 10 if that's more useful to you.
Increment by a different amount. Yeah.
Or we could even start a different number because we already have 100 products and we're adding into that. And I would like to start at 101. We can start a different number if we wanted to.
But so I guess the point is when we create the table, we specify this column is an identity column. We tell it what they call the seed in the increment, where to start from, how much to count up. And then every time I insert rows into that, I don't insert an explicit value into that column. It automatically generates a unique number using that sequence of numbers for that table. Yeah?
Yeah. I think just another point on that we need to remember, though, that in the future we may well delete one of those rows. They're not a counter. You can't go to the last one and say we've got 76 products because it's number 76.
Because we may have deleted 73 or whatever, yeah. So, yes, so we've got an identity is a fairly unique number that gets generated. We can insert into a table without inserting explicitly into that column. We just have the ID generated for us. And similarly, we might have columns that allow null. We've seen nulls quite a lot in this course. I might have a column that allows a null value. Perhaps it's a middle name column or something like that. And I can, explicitly insert a null, or I could just not insert into that column. And SQL Server knows that, well, this column allows null. You didn't provide a value for it. Therefore, it's a null. And the other thing that we can do is we can create default value constraints. So a classic example of this might be in an orders table. It's a sales orders table. There's an order date. And I might set up the table so that, well, by default, if you don't tell me the date, I'm going to assume it's today. I'm going to assume the order is right now. And it will insert the current dates and perhaps the current date and time into that column. So I could specify default values that are inserted if the insert doesn't specify what that value should be. I can use nulls and I can insert nulls if that value isn't provided, and I could insert identity columns. And like I say, like it says on the slide, you can explicitly specify null, or if you don't provide the value for that column, then if the null is allowed, then the system will let the row in and just put a null in that location. So that's inserting values. If I'm inserting a row of data, I can do that. I can also insert into a table using not explicit values that I'm providing as part of my application code or whatever, but I could insert the results of a query against another table. So if I want to transfer rows or duplicate rows in one table across into another table, then I could insert the results of a select statement against that table. And to be technical, I can also insert the results of an execution of a stored procedure, which we'll talk about a little later on in this course, which also returns rows that get inserted. So it's not just about inserting one row at a time. I can insert multiple rows that are the results of a query as well. There is one final option, select into. What select into does is it creates a brand new table from the results of a select statement. So if we talked about insert from a select, the table I'm inserting into would already have to exist in that case. If I use select into, I'm explicitly creating a new table and populating it with the results of the query. Now the new table won't have any constraints or indexes or primary keys or any of that kind of stuff. It's just a new table with a bunch of columns that contain the results of the query. And I guess one point we do need to make about that is that currently, at the time that we're recording this, is supported in SQL Server, but it's not supported in Azure SQL Database. So you can't use select into.
But you could create a table and then do an insert select.
Yes.
So you can get the same results.
Yes, if you know what the schema of the result is going to be, you could create a table ready for your results and then use a select into. So it's not really a major blocking issue. So we talked a little bit about generating identifiers, and we talked about this notion of an identity column. So in an identity column, we generate sequential numbers automatically every time a row is inserted. And you can specify, like we said earlier, optionally the seed and the increment. So I could, by default, it will start at 1 and go up in ones. But I could start at 100 and go up in tens if I particularly wanted to have a sequence of IDs like that. One of the obvious questions is, if I just inserted a row into a table, now this might be inserting an order, and the order ID might be an identity column. How do I then get what the order ID was back again? So if you think about an application on a website where you place your order, typically the first thing it then says is, thank you for your order. Your order number is, and it tells me.
So would you just go for the highest order number?
Well, yeah, there is a bit of a problem there because, of course, multiple orders could be getting placed at the same time. So there's a risk that between your order being placed and you going to find what was the highest one in the table, someone else might have placed an order.
Your order.
Yeah.
Right.
So there are all sorts of issues with that. To help you with that, there are a bunch of built-in global variables and functions that you can use. And we'll talk about each of those here. There's a global system variable called identity, which gets the last identity value that was generated in the current session. So for this connection, what was the last identity value I generated? Now that might be useful if I'm inserting in an order and getting back the order ID. You kind of have to be careful though, because if you insert an order and that order includes order details, which you then subsequently insert, and those have identity columns as well, then actually the last identity that you inserted will be the last of the order details. It won't be the order number.
It's the last identity on any tables.
Yeah, it's the last identity that was created in this connection. There's another similar, there's a function that returns something similar, although it's not scoped to the entire session, it's scoped to the current scope of the query, the current query that you've used. And that will bring you back, the scope identity is the name of the function, it will bring you back the last identity that's in scope of the query that I've just executed. Again, it might not necessarily be the one you're looking for if you had a statement that inserted into multiple tables and each of those had an identity. But that's possible as well. The other, and I guess the most explicit way of doing this is the ident current function, to which you pass a table name, and it will pass you the last identity inserted into that table. Now, that might sound like that's exactly what we need, but again, that's across all sessions. So if someone else is inserted in that table, it will get the identity they generated. So it's not an exact science. Typically in that type of scenario where I'm inserting an order with an order ID and I want to get that back, well, first of all, I try and avoid having identity columns on my order details. And secondly, I usually use scope identity to get back the value.
So you could grab that value before you go on to do other things that would then also use identity.
Yeah, and particularly if it's within a transaction, because you're going to get the value that's within your transaction before that transaction rolled back. And we will talk about transactions later on in the course if you don't already know what they are. So you can see the code example. I'm inserting into the sales orders table a customer ID and an amount, and I'm explicitly specifying the values that are being inserted. So it's customer ID 12, the amount is 2056.99, and then once the insert is done, I'm selecting the scope identity, and that's the order ID, that's the last identity that was inserted. Now there is actually another way of dealing with identifiers, and I guess we first of all need to set up why we need another way to do this. If you think about perhaps a database where you have two types of order, perhaps you have orders that are placed through your website, and you have orders that are placed by customers that you explicitly ship to. So you've got retailers that buy things from you, and you've got web customers that buy directly from you. Now you might choose to store those order details in two separate tables, because you might want details from the retailers about the supplier contact ID and the telephone number and the address of the store and all that kind of thing. And for your web customers, you might have a different set of columns that you want to store about those. So you've got different tables for your types of customers, and you might have different details for the orders themselves. So your retailer orders might include some sort of purchase order number, whereas your web orders generally won't have that because you want to raise the purchase order. So in that case, I'm inserting into two different tables, but I quite possibly want to keep my order numbers unique across both tables. And an identity column won't do that. An identity column is specific to this table. If I create an identity column on another table, then it will generate its own numbers independently. Now you could be clever and you could generate a seed and an increment on one table that makes sure everyone is an odd number and everyone on the other one is an even number, but really that's not the best solution. So an alternative is to use something called sequences. And a sequence is an object that you create in a database that generates sequential numbers, but it's not tied explicitly to any one particular table. It will generate, every time you need a new number, you just ask it for the next value, and it literally is select next value for the sequence, and that will give you that number, and you can then use that in any table you like as an identifier. So that would get around this problem of wanting to have a unique order number across two different order tables, or 3 or 4, however many order tables you've got. You just have this central sequence that controls, issuing new numbers.
So we could then union those web queries with those retailer queries, and it appears just as
these
it should.
These are all of our orders, and they've all got a unique number.
Unique numbers.
Exactly.